Everyone, now we have reached the second subtopic, which is called the equilibrium of a uniform rigid body. For a rigid body to be in equilibrium, it must fulfill two conditions. The first one is called the total force equal to 0. The second condition is total torque equal to 0. Okay, so this actually is based on Newton's first law that you have learned before. Let us read the questions. Figure above shows a uniform 500 Newton beam. Okay. The left end of the beam is hinged to a wall and is supported at the other end by a cable. If the cable can support 1800 Newton, what is the maximum weight? You see, the weight is here. Also determine the magnitude and direction of the reaction force R at the hinge. Hinge is over here. Okay, so in fact, I need to draw it out. Here is the hinge. Okay, so we need to find the reaction force at the hinge. All right. Okay, first of all, what should we do? Okay. He says okay, maybe we can label up. Yeah. First of all, we need to draw the free body diagram for this rigid body. Yeah. From in this chapter, we no longer consider the object as a point mass, no longer a point mass, but we see the object as a rigid body, a big body. Okay. And we draw the free body diagram based on a whole body. Okay, so basically, what forces do you think acting on the object? Okay, so I can say that at a hinge we have a reaction force. Reaction force normally is in this direction, assumed to be, and then we have the 500 Newton beam. Okay, the beam means the whole rod, the whole rod. This is the weight of the beam. Okay, this is the weight of the beam. So it acts at the center. It acts at the center, weight of the beam. And yeah, the weight itself also pulled the object down. Okay, this is the weight. I put as W1. Okay, better. Put as W1. And then the cable. The cable is pulling up. The cable is pulling up, so it is this way. Tension. Okay. Tension pulling up. Then the distance of weight from here is 0.7 L. So I can say that the distance, let's say the weight of the beam is actually at the center. Actually at the center is, so it is 0.5 L. The whole rod itself is L. Okay. Finish with that, we have angle theta here also, 30 degree. Okay, finish with that. And also the hinge I put as, I label as A. Yeah, this hinge I label as A. So, okay, here is a better diagram. Okay, I pre-draw. Okay, so so just now we know that at the hinge, it has a reaction force. At the center, it has a weight of the beam. And the weight which is hanging, we put as W1. And the cable is pulling up. It has tension, 1000. Okay, given the tension, here you see, the cable can support 1800 Newton. So this is the tension. This is the tension. So tension is 1800 Newton. 1800 Newton. Okay, the angle is 30 degree with the rod. The weight of the beam is 500 Newton. And this is the distance. The weight of the beam normally is at the center. At the center. The whole length is L. So at the center, it is 0.5 L. And just now the weight one is 0.7 L. Okay, it's given already, 0.7 L. Good. Now, we already have, so this is how we draw the free body diagram for a rigid body. You see the forces all they act at different point. They act at different point. So this is what we call a rigid body. You understand? This is a rigid body. It's not a point mass. Last time for the point mass, we draw all the forces at one point. Yeah, at one point. Let's say I have a block here. So what are the forces? We have forces here, all from the same point. Friction, friction has normal force, has the weight. So for point mass, all the forces concentrate at one point. But for a rigid body, the forces at different point, and these forces can make the rigid body to rotate. Can make it to rotate instead of just going left and right. Like this point mass, they just go left and right, up and down, no rotation. But when the forces act at different point, it makes the rigid body to rotate also. Yeah. Besides going up and down, left and right, it also can rotate in the process. Okay. So now, once we have finished drawing the free body diagram, what do? We resolve the forces. Okay, resolve the available forces. So for R, we have okay, the x component and the y component. This is here, and this is angle theta. Later we're going to find the theta also, the direction. So just put this as Rx. You don't need to put R cos theta. If you put R cos theta, also can work out, but it becomes difficult. Later you need to do simultaneous equation. Yeah, you need to do simultaneous equation. Better you just put Rx. Then you can just solve in one go. Okay. After you get Rx and Ry, yeah, because Rx and Ry, you just do Pythagoras theorem, and then you can get the R. And then you just do tangent theta, and then you can get the theta, the direction. Okay, so I prefer Rx and Ry instead of R cos theta and R sin theta. Because R cos theta and R sin theta, later you need to do simultaneous equation, then it's become a little bit more difficult. Okay, but either way can work. Yeah, either way can work. So now, the weight, the weight beam, the weight one, no need to resolve. The tension I need to resolve because it has angles. So okay, so this one is just put t cos 30. I have the angle already. Just put t cos 30, and then this one is the perpendicular component is t sin 30. Okay, yeah, good already. So you have done the resolve. Now it's time to put the values in the table. So do you remember the table? All these tables, it has the x and y components. But this time, we have one extra column called the torque. For the torque, you need to have an axis of rotation. The axis of rotation is at A. The axis of rotation is at A. A is the hinge. Why we put this as axis of rotation? Because this is the hinge. Hinge means the whole rod actually can move up or down except the hinge. This hinge is already pivoted. Is fixed, cannot move. It cannot move. It cannot move. Yeah. All the other places, all the other spots can move, but the hinge cannot move. The whole object will just rotate around the hinge. So we just put this as axis of rotation. Okay, that's how it goes. Axis of rotation at A. You must write this. Where is your axis of rotation? Yeah, you must write where is your axis of rotation. Now, let us try to do x and y first. After we finish with x and y, then only we go to torque. Yeah, and we do the simple one first. X and y. So, what is the x and y component for R? Okay, so the x component for R is Rx. So, Rx is going to the Actually, I don't know Rx is going to, you know, actually R can has two possibility. The R can go up, can go down. So I'm not sure whether whether is Ry is going up or Ry is going down. I'm not sure. I'm not sure. So that's why we need to find out. Yeah. So by the time I just at this moment I just put as Rx, yeah, for X component. Not sure whether it's going to the right or left. Just put Rx. Later, if you get positive sign, means it is going to the right. If you get negative sign, means it's going to the left. Okay? Never mind. So Ry also I'm not sure going up or going down, but I just put Ry. Later, the answer will reveal positive or negative to show that whether it's going up or going down. Okay? Whether it's going up or going down. So at this time for Rx and Ry, I don't put any sign at all. I don't put any sign. Just let the positive and negative sign come naturally at the final answer. Okay? Let us find out. So now let's look at the weight of beam. Weight of beam is going down. This one definitely is going down. It has no x component, so you just put 0. It's going down, so it's definitely negative. Negative 500 Newton. Okay? Never mind, I just put as first of all, I don't put any value. I just put the negative. I think can just put the value negative 500 Newton. And then what else? Okay. The weight one I don't have the value, but I know it's going down. So this one here put no x component, but just y component. So the weight one is definitely going down. Just put W1. I think I just better put this one as WB first. Yeah, put as WB first. WB. Okay. W1 is definitely going down, so it's negative W1. Now for the tension. For the tension, the x component is to the left. So to the left is negative. So remember, put a negative sign. Yeah. Because going to the left, negative t cos 30. And then t sine 30 is going up. So it is positive because it's going up. So it's positive t sine 30. Okay? Okay, now for torque, now let's look at torque. Okay, torque. For torque, the axis of rotation is at A. So same point as R. So is there any torque for R? Okay. Before that, let us go back to the formula for torque. Torque is actually Fr sine theta. So R is actually the distance between between force and axis of rotation. Distance between force and axis of rotation. So let's look at now. The force is the reaction. It acts on the axis itself. Yeah, it acts at the same place as the axis of rotation. Same place as A. It acts on the axis of rotation itself. So the R is 0. So the R here is 0. So when the R is 0, so the torque becomes 0. Understand? Because the distance between the force and the axis of rotation is 0. Because the R, the force, acts on the axis of rotation. So the R is 0. Torque 0. So R, you get 0 for no torque. You know, this R just cannot rotate the object at all. You see? Let's say this is the rod. The R is pulling this at the same place as the axis of rotation. How it rotate? Cannot rotate at all. Okay, cannot rotate at all. So the torque is 0. Now let's look at the weight of beam. So this beam can rotate, yeah? Rotate in which direction? You see, the weight of the beam is pulling down. It's pulling down. So it rotate clockwise. You see that? At the center here, rotate clockwise. So it rotate clockwise. Clockwise rotation is negative. Understand? Clockwise. Yeah, clockwise. Talk clockwise. Talk clockwise is negative. Talk anti-clockwise is positive. Just put like that. So, okay, so remember to put negative because it's clockwise, negative. Now, to find the torque, we always use the perpendicular component. This force is perpendicular. You know, this force is perpendicular. I mean the 500 Newton. Okay, the 500 Newton is perpendicular to the rod. So the force is already perpendicular. So now 500, the force, yeah, F is 500. R is the distance of the force to the axis of rotation, which is 0.5 L. 0.5 L. So 500 multiply 0.5 L. That's the answer. Or you just put it is the weight B. Okay, the force is the weight. The force, the force is the weight. The R, distance R is 0.5 L. 0.5 L. So just multiply 0.5 L. Okay, 0.5 L. So actually, do you know that the sine theta, here we have sine theta, actually is actually the perpendicular component of force. Yeah. So now in our case, our F sine theta, the whole thing is the weight of B. It's already perpendicular. The weight of B is actually already perpendicular to the rod. So our F sine theta is WB. Okay? WB. So, and our distance R is 0.5 L. Okay? So just remember this is the what we call the perpendicular component of the force. Okay? Now, let us look at the W1. W1, okay? See, this is the axis of rotation. W1 is pulling down. So the thing is rotating clockwise. Clockwise. So for torque clockwise is negative. Okay? So this thing will rotate the object clockwise. So it's negative torque. So here you get negative torque. So just put a negative sign here. Negative torque. Next is W1 is already perpendicular to the perpendicular to the rod. So is our F sine theta here. Our F sine theta is actually the W1. So our F sine theta is the W1. Now, how far is W1 from the A? How far is it? Yeah, 0.7 L. 0.7 L. That's it. Okay. Our R is 0.7 L. Okay. Now, our T. Okay. Which force? Excuse me. So which force? T, it has two components. T cos 30 and T sin 30. Which force responsible for the rotation? Okay. The T cos 30. Let's look at T cos 30. You need this object, T cos 30, you are pushing in this direction, pushing this direction. So will the object rotate? Will the object rotate? Not at all. It will not rotate because the force is parallel to the rod. no rotation. We know that for the torque, the F sine theta must be perpendicular to the rod, perpendicular to the R. So which force? Our F sine theta is actually the T sine 30. T sine 30. So the T sine 30 is like this, going pushing up. Do you see that? Pushing up. So this object will rotate anti-clockwise. You see? It will rotate anti-clockwise. So this is it. It rotates anti-clockwise. So torque anti-clockwise is positive. Okay. So this T cos 30 cannot rotate, but T sine 30 can rotate. So our F sine theta actually is the T sine 30. Our F is T, our theta is 30. You understand that? Yeah. So so the torque is positive. Why positive? Because anti-clockwise. It will this T sine 30 will rotate this object. Anti-clockwise. Do you see that? Anti-clockwise. Okay, you are brilliant. You understand. Okay, so now our F sine theta is T sine 30. Okay, so T sine 30 will rotate. T sine 30 will rotate the object anti-clockwise. And how far is T sine 30 from the axis? T sine 30 from axis is L. So just multiply by L. So our R here is L. Our R here is L. Okay? That's it. That's how you do it. This is so this part here all is the F sine theta. This part here is all R. Yeah, this is the R and this is the F sine theta. Okay? Good. So you got all the torque. So this torque will rotate clockwise. Okay, this torque will rotate clockwise. This torque will rotate anti-clockwise. Okay, rotate anti-clockwise. So now, here you see this negative force is going down. This force is going left. This force is going up. You see, going up, going down. This one is going left. Rx and Ry, not sure. Yeah, we will have to find out. So then we use the Newton. Okay, this is what we call the Newton first law. So we apply the Newton first law. Equilibrium is Newton first law. Total force equal to total force equal to 0. Total torque equal to 0 because this thing is is static. So total force is 0. So this is 0, 0, 0. Total Fx 0, total Fy 0, total torque is 0. So now we do the rest. So we start with the torque. Okay, start with the torque. Total torque equal to 0. So just add up everything equal to 0. Yeah. So 0, and then we have what? Negative what? Negative WB 0.5 L, and then what else we have? Negative W1 0.7 L, negative W1 0.7 L, and then what else? Okay, T sine 30 L positive, T sine 30 times L, get 0. You get 0 for everything. Okay, so what value do we have? Okay, so we have the WB. WB is 500. Okay, so later I just substitute WB with 500, and W1 I need to find. L, actually L can be cancelled out. This whole thing, the L can be cancelled out. Divide by L both sides. You divide by L both sides, You cancel off the L. So no need the L also. And then tension, tension is 1800 Newton. So you just substitute later on, you substitute by yourself. Tension is 1800 Newton. So you will get the final answer of W1, which is equal to 928.57 Newton. Yes, I got the weight. I got the weight, which is 928.57 Newton. Very easy, isn't it? Okay. Now, I got the weight one. This is the weight. This is the answer. Now, I want to find the reaction force at the hinge, which is this force. This is still unknown. This reaction force at the hinge. So, how to find? For this one, reaction force, it is at the, I can find at the x and y component, Rx and Ry. I need to find out what is Rx and Ry. Then I do Pythagoras theorem to find the magnitude and tangent theta to find direction. Very simple. So the way is total Fx equal to 0, total Fy equal to 0. Okay, so let's continue. So let's start with total Fx equal to 0. I have already done total torque equal to 0. Now total Fx equal to 0. Later total Fy equal to 0. Okay, so total Fx equal to 0. So Rx plus everything. Rx plus the negative t. Negative t cos 30. Negative t cos 30 equal to 0. The other is 0. So what is the Rx? Rx is t cos 30. So t is 1800. So in the end, what is Rx? I got Rx is equal to positive. Yeah, it is positive. Okay, sorry. Positive 1558.846. 846 Newton. Okay, positive means what? Positive means what? Means it shows that this force is going to the right. To the right. To right. Positive means the direction is going to the right. Yeah, so it's not going to the left. It's not going to the left. It's going to the right. So pretty sure, of course, because we already have one force to the left. One force to the left. T cos 30 is negative to the left. Of course, T Rx must going to the right. To balance out becomes 0. Common sense, isn't it? So this one must be going to the right because this one already going to the left. One force left, one force right to equal to 0. Equilibrium. Now, the next one, find Ry. Total Fy equal to 0. Yeah, total Fy equal to 0. So let's do total Fy equal to 0. Total Fy equal to 0 is just add up everything. You know, Ry, I'm not sure is going which direction. And then negative Wb. And then we have negative W1. And then we have positive T sine 30. Positive T sine 30 equal to 0. So what I have is the WB is 500. The W1 I got it just now. W1 is 928.57. 928.57. So I just substitute 928.57. And then the tension is 1800 just now. Okay, so I get the answer for Ry is equal to, I get the answer also positive. I get the answer also positive, 528.57 Newton. Oh, Ry is positive. Positive means what? Positive means it's going upwards. Positive for y component, when positive, it means going upwards. It's going upwards. So that means the resultant actually is, the R actually is to the right because we have positive Rx. And then we have going upwards because it has positive Ry. So this is our direction of the reaction force. This direction R with angle theta above the positive x-axis. Okay, above the positive x-axis. So our R is not going downward. Our R is not going downward. It's not going downward. The R actually is going upward. It's going upward this way. Understand? Because Rx is positive, Ry is positive. So the theta is above the positive x-axis. Okay? Very simple, isn't it? So now I want to get my R. I want to solve this question right away. So just use Pythagoras theorem, Rx square plus Ry square. Then just substitute our values, and what do we get? We get 1646.02 Newton. That's our magnitude of R. Next, the direction. Tangent theta equal to the Ry divided by Rx. Make sure you have the modulus to make it positive. So Ry divided by Rx, tangent theta. So anti-tangent, reverse tangent. And I get the angle is 18.73 degree. Is it enough? No, I need to say it's above the positive x-axis. Above positive x-axis. So that's the answer. Okay. So is the answer correct? 1646, 1873? 1646, 1873. Yes, above positive x-axis. Yes, 928.57. Yes. Okay. So that's our way to find the weight and reaction force at the hinge. Very simple. Yeah. So the way is just use total torque equal to 0. Total torque equal to 0. Total force Fx0, Fy0. Do all the components. Yeah. Xy torque. Draw the correct free body diagram. Okay. The rotation clockwise negative, anti-clockwise positive. Yeah. Resolve the forces into component first. So these are the way to do equilibrium of a uniform rigid body. Thanks for watching. Thanks for your time. Stay tuned for the upcoming videos. Bye.